The coffee sector plays a significant role in Kenya's economy. About 700,000 households derive their livelihoods from coffee farming. In line with the government's strategy to revitalize agriculture as a key sector of the economy, the Coffee Research Foundation has developed various interventions to improve coffee farming, which encompasses the use of good agricultural and processing practices. Coffee nutrition is vital for plant growth and high productivity.
Optimal nutrition means that we can get the maximum production that the plant can afford. Every step towards optimizing production corresponds with an increase in production, and it also corresponds with increase in canopy size.
Coffee plants require both macro and micronutrients for high production of quality coffee. Macronutrients include nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur. On the other hand, micronutrients include zinc, boron, iron, copper, manganese, and molybdenum. Note that soils are unable to provide the required nutrients in the right amount at the right time due to leaching and excess utility.
As we harvest coffee, we are in effect withdrawing both macro and micronutrients from the soil, and that means the soil is being debited the same macronutrients. If we take 1 metric tons of coffee, it will mean that we are removing that 4 kilos of nitrogen, 56 kilos of potash, and 8 kilos of phosphate. We need therefore to replace the same macronutrients through processing waste recycling and applying the recommended fertilization regime.
Nitrogen promotes vegetative growth, improves crop bearing capacity, and increases the proportion and size of premium beans. Phosphorus, on the other hand, is important for root development, wood formation, berry formation, early maturity of beans, and enhanced berry density. Potassium is critical in the translocation of synthesized food, berry development, ripening, mucilage formation, and high water utilization.
The macronutrients are mainly elements that are some of which are incorporated into the plant tissue, and some which are players in the processes. Nitrogen is a player in photosynthesis, and it is also a constituent of the plant tissues. Phosphorus is an element which is functional in terms of energy mobilization in the plant and also in the composition of some tissues like seed. It is regarded as part of the life giver of the plant. Potassium is an element that is very useful in movement of manufactured goods, that is glucose, from the point of manufacture, the leaves, to the storage organs, that is seed, stem, and root storage areas. When it comes to calcium and magnesium, calcium is a player in root development and also in production of flowers and development of apical points of the plant. That is the apical, the head points, growing points, and it works closely with boron. Magnesium is a constituent of chlorophyll, and it is related to oil manufacturing processes in the plant. It is an important element also in the soil, in that it controls the pH of the soil along with calcium. The ratio of magnesium to potassium is important in balancing the nutrition of the plant. Sulfur is an important secondary macronutrient in the formation of leaves along with iron. It is also important in the formation of biomolecules in the composition of the bean.
Macronutrients deficiencies impact negatively on the coffee plant.
Plants talk by way of colors, the color of the leaf, also by the position, the relative orientation of the leaf, and sometimes you may also notice that there are deaths of certain parts of the tissue like the tips, or dead around the leaf margin, and all those are ways of expression by the plant.
For example, nitrogen deficiency leads to the yellowing of leaves, which cannot manufacture food, leading to small beans of low quality. Lack of phosphorus leads to serious defoliation of mature leaves, weak bearing heads, low density of coffee beans, and poor bean grades.
If the leaf is going beyond yellow and going to bronze color, and very likely the leaves pointing backwards instead of pointing forward, it shows that there is shortage of phosphorus.
Potassium deficiency is characterized by drying of leaves at the margins, delayed ripening of berries, poor bean development, and nipping of beans due to inadequate mucilage, which leads to low bean quality.
The micronutrients are mainly elements that the plant uses to regulate functional processes. So they serve as catalysts, biological catalysts in the plant. They sponsor controlled processes like photosynthesis, flowering, fertilization, development of the apical shoots, protein synthesis, water uptake, and many other functional processes. To stimulate flowering, coffee needs to be sprayed with micronutrients, boron, and zinc at 40 to 60 grams per 20-liter knapsack. And this amounts to 2 to 3 kilos of the two micronutrients per hectare in 1,000 liters of water. The best times for application of zinc and boron foliar sprays is January, that is 2 to 3 months before flowering, and August, which is 2 to 3 months before the next flowering.
Zinc is a crucial micronutrient. It boosts flower initiation, bud formation, and enhances fruit setting and leaf size, while boron promotes shoot growth, facilitates optimal flowering and fruit set.
The other feature that clearly shows boron deficiency is the fanning shape of a primary branch. The secondary branches express themselves like a fan. We don't have a definite terminal growth. You can see that this point is where the terminal shoot ended, and it branched into twin secondaries, but it is yet to grow to the terminal shoot. This is a clear indicator of boron deficiency.
The major sources of zinc are zinc oxide and zinc sulfate, while boron can be gotten from borax and soluble. Although required by the plant in small quantities, iron helps in chlorophyll formation and enhances coffee quality. Lack of it results in leaf chlorosis and inferior quality beans referred to as amber beans.
Sometimes iron deficiency can occur even if the soil has enough iron due to acidity of the soil. When the soil is acidic, it increases the activity of magnesium in the soil water, and this affects the amount of iron in the soil water, and the plant is not able to access enough iron. So instead it gets more manganese and it expresses iron hunger.
Proper soil management is a prerequisite to good coffee production. Towards this end, soil analysis establishes the actual nutrient status of the coffee farm. It is the outcome of the analysis reports that determines the suitable nutrient regime through which to develop the general fertilizer application guidelines. Depending on the regions, soil and leaf sampling ought to be done during dry periods, for example, December to January and August to September. This should be done every 2 to 3 years.
We assess the nutrition of the plant, in this case coffee, by analyzing the soil to see the relative levels of the macronutrients and micronutrients and relate with the minimum sufficient levels. And from there, we try to make up by correcting with fertilizers. The key thing is to analyze the soil and also possibly analyze the leaf tissue to see whether there are gaps in terms of the supply from the soil, and also whether there are gaps in terms of the content in the tissue.
Let's turn to the application of fertilizers.
NPK refers to the co-formulation of nitrogen, phosphorus, and potassium.
250 grams of NPK compound fertilizer should be applied per coffee tree 6 months before the main flowering. That is around September for Western, Nyanza and Rift Valley provinces, and October for Central Province and Embu District. For Meru, Machakos, Makueni and Taita Taveta, application should be done in the month of April.
The grade of NPK is the composition of each of the macro elements NPK per 100 kilos of the material. Nitrogen is expressed as direct nitrogen. Phosphorus is expressed as phosphorus pentoxide, P2O5. That is a standard international way of writing. So when we talk about 1717, we say we have 17% nitrogen as nitrogen element, 17% of phosphorus in form of P2O5, and 17% of potash expressed as K2O, potassium oxide. Those are the standard grade expressions.
This fertilizer should be applied 2 weeks after the onset of rains and be incorporated shallowly in the soil.
The farmer can easily maximize the use of fertilizers by terracing the land to ensure that there is no soil erosion, and by making sure that the weeds do not grow beyond fourth leaf stage. When weeds grow beyond fourth leaf stage, they end up taking up a lot of nutrients, sometimes very, very fast, and thereby frustrating the initial uptake of phosphorus, nitrogen, and potassium when compound has been applied. And at the end of the day, they will frustrate the upcoming second season of flowering, because the plant will not have taken enough potassium, it will not have taken enough phosphorus, and it will not have taken enough nitrogen. A lot of it will have gone to the weeds. So competition by weeds should be discouraged by early use of herbicides or manual weeding.
Zinc and boron should be applied 2 months before the main flowering. Nitrogen fertilizer is applied at 300 grams to a tree 2 weeks after the onset of rains in splits. That is, 2 splits for the east of Rift Valley and 3 splits west of Rift Valley at 4-week intervals.
We have 2 classes of byproducts of coffee. One of them is pruning byproducts, which we call pruning trash. The pruning trash contains a lot of nutrients which have been taken up by the plant. When those prunings are concentrated in trash lines between the rows, they will decompose and they will also obstruct soil movement, and the two add up to improving soil fertility in the soil. The other class of byproduct is the coffee pulp. If coffee pulp is composted well, by turning it every 2 weeks, up to about for 2 days, it will become a very fine compost, which will return about 40 kilos of nitrogen per ton and 6 kilos of potash per ton. So it is possible to return some of the nutrients which were taken by the beans, but which were in the pulp, back to the farm. And this will help in sustaining the productivity of the farm.
Manure application is also good for the coffee plants. This should preferably be done in February to March and August to September. 1 to 2 debes of well-composed manure per tree per year will do. In addition, foliar feed is a fitting supplement during the dry periods of the year, when crop bearing is heavy and nutrient deficiency is observed.
The advantage of foliar spray is that it is faster. It takes from a number of hours to a number of days for the plant to get enough of what it requires. So it is a quick remedy of correcting hidden hunger and also imminent hunger. The final indicator of a happy plant is a dark green color and also shininess, reflectance on the leaves. When you go on a sunny day to the field and you find the plant is dark green and it's also reflecting light, that is what we call optimum nutrition. Optimum nutrition means that we shall get fat beans, fat ovoid beans, and we shall also get very high carb quality.
The practice of soil liming is ideal for the improvement of the soil condition. Lime is best applied during the dry months when the soil analysis has been done.
Sometimes the soil is highly acidic. When it's highly acidic, we correct the acidity by neutralizing it with a base like calcium carbonate, which is commonly called calcitic lime. We also neutralize it with calcium magnesium carbonate, which we call dolomitic lime. Both limes are equal partners in neutralizing the soil, but if the soil is low in calcium, we prefer the calcitic lime, a certain percentage of calcitic lime and a certain percentage of dolomitic lime. So we blend the two, but to tone up calcium, to ensure that calcium is more in the soil than magnesium.
By sticking to good nutritional techniques alongside other recommended agricultural practices, coffee farmers stand to reap maximum yields from their crop. This way, they will look forward to good returns from their farms.
My appeal to the farmers is to follow the procedures which are laid down by Coffee Research Foundation to assess the status of their soils and coffee plants, to find out what deficient elements are likely to affect their crops and what elements are adequately supplied. And at the end of the day, they will save on using the right fertilizer and sometimes not using certain fertilizers which are not needed.